Hello students, welcome you all to the CBSE Chemistry lecture series. Last video we discussed the colligative properties of the chapter Solution chapter standard 12th. We discussed the colligative properties. In the colligative properties, few properties like lowering of vapor pressure, elevation of boiling point and depression of freezing point. That all we discussed in the last video. Now in this lecture we are going to discuss the concept of another important property called osmotic pressure. Let us define what is meant by osmosis. Osmosis is defined as, say for example, I will draw the diagram for this case. So we are having a SPM semi-permeable membrane. Okay, this side, say for example, we will take a concentrated copper sulfate CuSO4, and this side we are having a dilute copper sulfate solutions. First we will define what is by osmosis. Osmosis is a process of the net flow, spontaneous flow of the solvent molecule from the solvent to the solution side. Here in this case, this is a solvent side to the solution side. This is a more concentrated copper sulfate, is a solution side. Through a semi-permeable membrane, is called osmosis. The movement of solvent molecules from what? Lower concentration to higher concentration side through a semi-permeable membrane is called osmosis process. Yes. Now in this case, before defining osmotic pressure, first we will explain that SPM stands for semi-permeable membrane. This semi-permeable membrane, there are two types. One is a natural one and another is an artificial one. The natural one is nothing but animal bladders. Say for example, pig's animal bladder is naturally a semi-permeable membrane. The artificial semi-permeable membrane is also there, that is parchment paper, cellophane sheets. These are all artificial semi-permeable membranes. So in this case we are going to discuss that what? Osmotic pressure. What is meant by osmotic pressure? One side we are having a solvent molecules, the another side we are having a solution side. In the concentrated solution side we are having a piston. So we are going to apply a pressure on the piston side. So the minimum excess pressure that has to be applied to the solution side to prevent the entry of solvent molecules through the semi-permeable membrane is called osmotic pressure. What is meant by osmotic pressure? So we are applying a minimum excess pressure that has to be applied on the solution side. That has to be applied on the solution side. Immediately what will happen? Osmosis process will be stopped. So that particular pressure is known as osmotic pressure. So what is meant by osmotic pressure? It is denoted by a symbol pi. Yes, when we have expression for this pi, or osmotic pressure, how we can say the osmotic pressure is directly proportional to the concentration of solution. Osmotic pressure is directly proportional to the absolute temperature T. When we combine these two things, it's nothing but pi is directly proportional to Ct. So the proportionality is what you have to do, you have to put a constant CRT, where R is known as gas constant. R is a gas constant. So still you have to modify this one. What is by concentration? Concentration is nothing but molarity, number of moles of solute present in 1 liter of the solutions. That is called molarity, or you can say concentration of solutions. So this you have to modify this one. Number of moles is nothing but given mass by molar mass of solute. If you express in what? ml, then 1000 divided by Vml. So in the place of C, you are substitute in this case. So V pi is equal to W2 by M2 into 1000 divided by V ml into RT. This is a formula for calculating molecular mass of a solute. If you want to find out a M2, then you have to use this one. Next, we will see some few examples from the NCERT in-text questions as well as exercise problems. Well, let us define this NCERT in-text problem or work out the problems. Calculate the osmotic pressure in pascals exerted by a solution prepared by dissolving 1 gram of polymer of molecular mass 1,85,000 in 450 ml of water at 37 degrees centigrade. First, you have to see it's an in-text problem 2.12. First, what is the given data? You have to write the given data first. W2 is given as 1 gram. M2 is also given. Molecular mass is what? 1,85,000. Then volume is also given as a 450 ml. And temperature is what? Given as a 37 centigrade. You have to convert it to Kelvin scale. That is 310 Kelvin. Yes, that's all the information is given. The question is what? Osmotic pressure in pascals they are asking. So this is a given data. Okay. First we will take what is the formula for calculating the osmotic pressure? Pi is equal to CRT, that is modified to what? So pi is equal to W2 by M2 into 1000 divided by V ml is given into RT. This R is also constant. What is the R value if it is expressed in pi scale means 8.314 into kilopascals. You have to put a 10 to the power of 3 pascals. So this value you have to substitute in the place of R. So W2 is given as a 1. M2 is what given as a 1,85,000 into 1000 divided by 450 ml into R value is also given 8.314 into 10 to the power of 3 pascals into temperature is also 310 Kelvin. If you simplify it, 30 is there 30. Okay. Then we can cut the 10 and simplify this one. It will comes about 30.96 pascals. So this is the answer for this problem. Okay. Yes. Now we work out the NCERT exercise problems. That is 2.22. At 300 Kelvin, 36 gram of glucose present per liter in its solution has an osmotic pressure of 4.98 bar. The pressure is expressed in bar here. If the osmotic pressure of the solution is 1.52 bar at the same temperature, what would be its concentration? They are asking. So you have to write the formula for this case. Pi is equal to CRT. This is a formula for this one. There are two cases. One case they are given as a 4.98 bar. That pi is given. So you would say first case. So 4.98 bar is equal to, what is the concentration is given? Yes, concentration is what? 36 gram. 36 gram of glucose they are given. So that is W2. You have to write the data first. W2 is what? 36 grams. M2 is what? Glucose C6H12 O6, that is equal to 180. And that's all. These values are given here. So you have to write this one. So 36 divided by 180 into RT. The volume is what? 1 liter. So you don't want to express this one. So okay, in this case, this is the first case. Similarly for second case, so 1.52 bar is equal to CRT. This is a second case. In this case, temperature is also given as a what? 300 Kelvin they are given straight away. You have to use that value into 300. Here also you have to use 300. So dividing 2 by 1. So what will be the answers? In this case you have to simplify it. 1 0 1 0 cancel. Then you have to use that one. That is what? Is 1.52 bar. This is the second case I am writing. Equal to C. Yes. 300. R will be cancelled. And divided by the first case, that is 4.98 bar. This also you are simplified, we are getting a 60 R. R cancel. Now you want to find out C. What is the C value? C is equal to 1.52 into, we can cancel the 0 also. 0 5 times. So in this case C is equal to 1.52 divided by 4.98 into 5. So C is equal to 0.061 m. C is equal to 1.52 divided by 4.98 into 5. If we simplify it, we are getting a concentration of 0.061 m. So if you have any doubts, please mention in the comment box. Thank you, students.